Now suppose that we want to solve the following equation. 2 to the power x plus 2 to 1 over x equals 4. So we don't have a way to get the solution exactly by looking at the equation, or we have a systematic way to solve this equation. But we can do something else. So first we assume that x is a natural number. X is in n. But here we see that 1 over x has to be different from 0. That means x is different from 0. Okay? In n, to have this one in n, 1 over x, to be in n, that means 1 over x has to be 1. Because we know that 1 is only 1 that can be written in this form. But this means that x is 1. We check that 1 is a solution. So we have 2 to the power 1 plus 2, 1 over 1, which is 1, equals 4. That means 1 is a solution. And in n, this is the only one. This is the only solution that we have. So that's the only number that we can see. But are there any numbers that can solve this equation? So now, to see that we have no other solutions, we can either study this function f of x, 2 to the power x plus 2 to 1 over x minus 4, okay, and find a number such that f of alpha is equal to 0. And this is the solution that we are looking for. And alpha has to be in R. But there is a quicker way, okay? So if we don't need to study this, because when we differentiate, we're gonna have some powers of the log and the 2 to the power x and minus 1 over x squared times the log of 2 times 2 to the power 1 over x, and it's gonna be a bit messy. But there is a quick way to solve this problem. We can just graph this one here, because we are looking for the solution and we found one. We want to make sure this is the only one. Okay, so a quick way to find out is to graph this function. Okay, so sometimes, okay, so if we can graph the function and we see that's increasing and it has some number that's a 0, that's a solution for, let's say this is our beta here. We have f of beta is 0. So if f is increasing, that means this is the only solution. But sometimes you can have a function that can just hit the graph, the x-axis, and get and make 0. So let's see this one here. Let's graph this one. Okay. So first, okay, this function, let's call it f of x, 2 to the power x plus 2 to 1 over x minus 4. Okay. So we said f of 1 equals 0. So this is 1 here. So this function is defined for all the x's different from 0. So let's write this one. Let's draw this one in red. Okay. So first, when x is less than 0, we have 2 to 1 over x goes to 0. Okay. And 2 to the power x goes to 1. So this one behaves, when x is less than 0, behaves like 1 minus 4 behaves like minus 3. So it's like almost, because we're gonna see some change, it's like minus 3. Okay, it's negative. So here, no solution. It doesn't hit the x-axis. But when we check the limit as x goes to 0 from the right, so that means we come in closer to the x-axis. On the x-axis from on 0 from the right, we see that this is 1. Okay, and this one goes to infinity. 2 to the power 1 of x goes to infinity. That means it's like this. And it keeps decreasing until we get to 1, where it becomes 0. After that, it increases. Okay? That means the 1, this is our only solution. Okay? So this equation has only one solution, and it's given by x equals 1. There are no other solutions. We can study this function in detail. F of x, 2 to the power x plus 2 to 1 over x minus 4. When we differentiate f prime of x, we get ln of 2 to the power x minus 1 over x squared, ln of 2 to 1 over x. So here we factor by the log of 2, and we get 2 to the power x minus 2 to 1 over x squared. And we study the sign of this equation to see where the function is increasing or decreasing. But a graphical approach, by just looking at the function and taking the limits, would show that this is the only solution. This proves that x equals 1 is the only solution for this function.